All right, folks, let's get ready to re-engage here. Welcoming a whole new group of folks here on the YouTube channel. Welcome to all of you that may be joining us there. I appreciate you coming in. And Brian, I see you have joined the party here as one of our audit students. I want to welcome you and encourage you, by the way, while you're here. Brian, feel free to participate. If you have any questions or anything you would like to ask, and then you feel free to do just that. You can jump in with your you can type it into the chat box, use your raise your hand icon, whatever. However you would like to signal me. I always welcome the questions and treat those as an opportunity. So feel free to participate while you are here, and welcome. All right, still got a couple of folks here. I would like for you guys to go ahead and make certain that you send me your bio. Two of you that have sent that already, I really appreciate that, and that gives me a little bit more information so that I can fine tune this class to your needs. Okay. So those of you that have not sent that to my email, please make certain you do so. Now, very good job on the lesson quizzes, and of course, you proved me right. By the way, those of you that completed the second quiz, you see you're great. Your scores went up on that. And they do every time. They always go up, and that repetition of those quizzes is an excellent tool that is required for you guys to really drive home the answers in the quiz questions. For those of you that downloaded the materials off of the Wormhole site as well, those are also excellent training materials that are designed to prep you to pass these certification exams. I got an email from a student that I had over the last 2 weeks, and he was telling me that he had passed his Security Plus exam. Yay. I'm mighty proud of him for that. And you guys make certain when you pass your exams, make sure you let old crusty dude know here now, because I like to celebrate those as well. So, all right, the first two lessons that we covered this morning, the first was a basic overview and introduction of systems in general, cabling types. We looked at your motherboard in a pretty good bit of detail, showed you all of the different areas of the motherboard where you would configure a, a CPU and installing your RAM cards. You know, one of the most important things that I wanted you to gather out of that was the necessity to absolutely read your instructions. Make sure that you read the configuration requirements on the motherboards. You have to make certain that you match up the motherboard with the proper CPU, the proper RAM cards that fit in the RAM expansion card slots there that you have, or the RAM card slots, and any expansion cards that you purchase for the device. Also make certain that they are indeed compatible with the appliance itself. So mainly just reading the instructions there to assure that you are selecting the proper equipment that will go with whatever your configuration might happen to be. Okay, so very, very important there. I'm going to tell you a little anecdote there. I always tell my students is my oldest granddaughter, who is getting ready to graduate high school, by the way, this year. When she was a little bitty thing, she is it couldn't have been more than 2 years or so. She's riding in the back seat with her granny and I. And my wife was driving, and I was trying to work on the wife's mobile phone. And whatever it was I was trying to configure just wasn't working like I expected it was supposed to. So I'm grumbling and fussing. And the wife says immediately, and all the kids call me Gampa. She looks at me, she says, Gampa, did you read the instructions? And a little bit in the back seat there immediately pipes in. She says, yeah, Gampa, did you read the instructions? So I always tell my students, make sure you read the instructions when you get ready to configure these systems to make sure everything fits together properly. And it all is configured and based upon the specifications, primarily of the motherboard. Okay. Now, there will come a time in your A+ world, and I noticed a couple of you that did send me your bios, You probably have already experienced this when you start needing to troubleshoot issues that are happening with hardware, your PC. Now, of course, it'll go on later on into software and that kind of thing as well. But hardware issues fall in some of the first ones that we tend to take a look at. And you have to approach it with a very specific phased methodological approach. Now, CompTIA A actually have claimed this troubleshooting methodology as their very own. It is a phase step-based process. They have 6 steps in there. And I'll tell you, I've been in the IT world longer than CompTIA A has been in business, and we always use this exact same troubleshooting model. It is very specific, and there are very specific things that we do along the way in each one of these steps. I'll go into quite a bit of detail in each of these. In this order, identify the problem, establish a theory on what you think may be causing the problem. Then you test that theory out. Once you have determined that you have indeed identified what is causing the problem, then you need to establish a go forward plan, an action plan. Now, during that particular step, you're going to find several things may occur and decisions that have to be made before you proceed forward and get in and fix the problem. Once you have addressed the problem, mitigated the problem, fixed whatever it was, then you need to verify for yourself that the problem is indeed been fixed, and to your best knowledge and best understanding of the system, that it is fully functional. But I want you to remember, it ain't fixed until the user said it's fixed. So you verify full system functionality. And then after that, the user needs to verify that, yep, the system is back to at least the same state it was before it got broken. And that they basically sign off on it. Now, all through the entire process, doesn't matter. You need to document each and every step along the way. Now, these usually begin with someone somewhere in the environment filling out a help desk ticket or calling the help desk, and somebody in essence opens up a ticket for this. So at the end of the process, you need to make certain that all of your documentation is gathered together, put in as part of the description and the information that coexists with whatever ticket was opened up. And if there wasn't a ticket opened up, you open one up, and you need some kind of a ticket tracking system, of course. And those are very easy to come by. Actually, even in Microsoft Access, there is a template structure already set up there. It has forms, it's got reports, it's got a database already created for doing a help desk type of a system there. So whatever system you have for tracking the incidents, make certain that all the documentation is updated, basically cross all the T's and dot all the I's, and then close it down. You close the ticket. Now, I always look for, as I'm going along here, step number 7 for me would be a training system. I always try my best to look for teaching moments and throughout the entirety of the troubleshooting model and methodology. Okay. But that's pretty much the items and the steps that we go through there in general. Now let's look in more detail. Identifying the problem. One of the best ways to identify the problem is by asking whomever the user might happen to be, and those might be around the organization for that user, a whole bunch of open-ended questions. And you guys know open-ended questions begin typically with what, where, when, why, how, and who. Open-ended questions are designed to engage the user in conversation. They are also, if you use them cleverly, designed to calm the waters a wee bit, because you'll find that in a lot of cases, that user, they may be out in the field, they may have a supervisor breathing down their neck, got to get these systems up and running right now. So you may often encounter hostility, or what seems to be hostility. And in many cases, according to how much pressure that user is under out in the field, they may make you believe that you're the problem, that you're the one that broke the system. So by calming the waters, asking the questions, engaging them in conversation, you get good information if you do it properly. And open-ended questions as opposed to closed-end. The closed-end question can only have two answers, yes or no. You don't get very much information in that instance. Now, sometimes a yes or no question is required. But in order to engage the user, to calm the waters, get as much information as you possibly can, um, to help you identify the problem is the best way to approach that. I've also found if I can recreate the problem, especially if I'm working remote and I don't have hands-on on the system there, answering a lot of those open-ended questions and then seeing if I can recreate the problem on my end, or if I happen to be on site, I'll try my best to recreate the problem there as well. Now, I always want to make certain that either I or the user or the user's operations personnel, wherever they happen to be, does a complete system backup before we jump in and start trying to make any configuration changes, upgrade systems, things like that. But if I can either, like I say, on site, recreate the problem, then I'm way down the road as far as figuring out what actually caused the problem. And ask things such as, when was the last time that you remember the system was working properly? And what, if anything, has been changed since then? Has there been hardware upgrades, software upgrades, infrastructure changes, add-ons, anything like that? And then start backtracking and working on it. And try not to get overwhelmed. Don't try to look at too many things at one time. And most certainly look at hardware-oriented issues first, because those are the ones that typically become more apparent. Okay. So once I begin to question and gather as much information and then determine at least a theory as to what might be causing the problem, well, then I test it. And I find out pretty quickly if the theories that I'm testing are indeed the cause of the problem. But don't look past things such as, take a physical interview, as it were. Observe the systems. Look for physical damage. I was called to do some work on some systems decades ago, and when I first went into the cube space where there was actually two different systems, but there were dents, I mean deep dents on one side of the system enclosure. And it was making noise. There was no doubt the fan inside the power supply unit was contacting something, sound like a Gatling gun. And then with very little questioning there, the one of the users told me that they felt like the cleaning crew, and I don't know if they were telling me the truth or not, somebody had knocked the system over. Because she said when she came in that morning, it was laying on its side and it was making the noise. So I don't know, somebody bumped it or gouged it, maybe it's sitting on the tabletop. I don't know, because I was not there. But that's the story I got. The system was laying on its side when they got into work that morning. So pay attention to that kind of stuff. Listen. If you smells like rubber or plastic burning, there may be an issue there. So pay attention to those things, and again, don't take anything for granted, especially if you are communicating with the user from a remote location. And even though it may seem silly on the surface, and when you're asking somebody, well, is it plugged in? Is it turned on? Believe it or not, those oftentimes are the answers to questions that, yeah, you got to plug both ends of that cable in to make it work properly, you see. So again, don't assume anything. Don't hesitate to question what might seem obvious to you as a support tech, because understand, the majority of people that are using systems out in the field are not deeply technically oriented, so they don't think about those things like a support technician might happen to be. If I test a theory and it proves out not to be the case, back to the drawing board, come up with a new theory and then test it along the way. Now, once you get to that point and you just can't figure it out, well, don't be afraid to, I'm not saying give up, don't toss the towel in, but ask for help, because there's always somebody in your orbit that has a little bit more experience or different experience than you may have. So don't be afraid to ask for help. Okay. So escalate it up to somebody that is above you, supervisor, and etc. If you do, oh, excuse me, if you establish the theory and have figured out what is actually causing the problem, you may also, when you are getting ready to go with your go forward plan, you may realize at that point, this has happened to me in the past, to where the mitigation to fix the issue was going to require money spent that I didn't have the authority to give the okay for. Okay. Replacing hard disk drives, replacing a cracked monitor, that kind of thing. So in that case, I needed to elevate that to somebody that was above my pay grade to make those decisions. Knew what the problem was. I couldn't make the decision to, get a new $1,200 system or whatever. So that is part of the plan of action there. And you have to understand too, if systems are going to be out of service, and especially if those out of service systems has a domino effect and affects other stakeholders, we got to make certain that everybody is communicated with properly there as well. Sometimes that's upline to a supervisor, sometimes it's lateral to other workers on the same level as you. But you got to understand what the cross system impacts may happen to be there, especially if it's going to cause work stoppage downline somewhere. So all of the stakeholders have to be kept in the loop. We have to make certain that, if I need to order equipment, there's a time frame, a time lag as far as the equipment being delivered. Everybody's got to be kept in the loop and made aware of what the delays might happen to be. And as I was saying, all along the way, document, document, and document. Okay. And I'm not talking about documentation be written, crammed in a file folder, never to see the light of day again. Ooh, I want electronic documentation. I want it kept in preferably a relational database ticketing system that I can use for multiple purposes down the line. One of them being justifying my existence. If my boss wants to know what all I've been doing, there goes my printed reports of all of the support functionality, date and time stamp stuff that where we spent our day. Okay. But it also gives me information that if the same thing occurs down the line and I'm not, the technician to handle it, well, somebody else can refer to that and use that information as a shortcut. So I always tried my best to meta tag the data with search terms and so on to make it very, very simple for anybody, of course, with the proper security and access, but anybody to be able to search the information and pull detailed information out about all of the service tickets there, no doubt. And like I say, you guys should actually check out the ticketing system template that's available in Microsoft Access. It's really good. And Microsoft Access is a great little database for those of you that need any, ready-made rubber stamp kind of systems. And they have just this whole library, vast library of free systems, free databases that have forms and reports. And I mean, really good stuff there. So that's the overall troubleshooting methodology that's offered up as their very own, by the way, by CompTIA A. But it's been around forever. And it's not just for troubleshooting computers. I mean, you can use that same troubleshooting methodology when you're troubleshooting basically any kind of technically oriented issue. Okay, same steps. And as I said, me personally, I always am on the prowl for those teaching moments. If there's something that I can do, something that I can use as an example, do when I'm doing a fix and train the user, well, I have expanded their horizons and I've also made me quite the cohort there going forward. Okay. So they can be a support mechanism out in the field later on if need be. Okay. And most people relish the opportunity to learn some stuff that's outside their bailiwick anyway, especially if it relates to their job function. Okay. Now, this is more from a operating system software side of the house, but it is a very common configuration function that we find that A+ technicians need to get into. And there's two different flavors of it still floating around out there. Some of the older computer systems, older legacy type systems, operate, and it's still called the same term, but it's been quite the security update down at the motherboard level, in what's referred to as the system firmware. That's the system firmware chip that's attached to the motherboard. Well, it has instruction code sets and configuration information. It's called BIOS, Basic Input Output Systems. The older versions of it was older legacy stuff. They had the BIOS menu that came up, and there's actually a means of getting to that menu during the boot up process. The newer versions of it now, there's a couple of advances on the newer systems now. People still refer to it as BIOS. The official terminology is UEFI, Unified Extensible Firmware Interface. One major advancement in that is in the old BIOS systems. You'll see here just a second example of the menu, but when you interrupted the boot process and brought up the system firmware menu, it interrupted the process prior to the loading of the mouse driver. So you couldn't manipulate the menu with your mouse. You had to drive it with the keyboard by way of the keyboard. Function keys had certain assignments. The arrow directional keys allowed me to navigate up and down the menu, and the lateral keys crosswise in different menu items and options. Many times I'd use the space bar to select a highlighted option, things like that. So it was a keyboard manipulation kind of menu system rather than the mouse. Now, the newer version of it, this guy here, that is a more modernized system. That's the Unified Extensible Firmware Interface. And at this point in time in the interrupt process, the mouse driver is indeed loaded, so you can manipulate this in many cases with the mouse. To get to that setup menu under the covers there, the firmware interface, when you start the system booting up, when you first start the boot up process, immediately when you see the system logo, whatever the system logo might happen to be, Asus, Dell, HP, doesn't matter. In the boot process, when you first see that, you start pressing a function key. In most cases, that function key nowadays is typically function 8. In some of the older systems, it was function 2. Some of the older systems, it was function 12. Some of them even use function 10, different operating system environments. Now, I think for the most part, the interrupt key there is F8 for most systems. This is the old BIOS type menu. Notice the items down across the bottom of the screen here. Up and down arrow to select the menu items. The space bar, okay, or the plus or minus key to change values. The escape key to exit the overall menu itself. Then, of course, F1 has typically been your help key there. Okay, so pretty typical. There are a couple of dozen different items that are hanging out behind this menu. Now, some of the things that I can adjust here is, for instance, where I'm booting the system from. Am I booting it from a hard disk drive? Am I booting it from a USB flash drive or a DVD drive? I can do things such as set an administrative password, for instance. There's a default administrative password that comes configured with all these things. You should actually change that. That's part of what we call hardening the device. Do things such as change the functionality of function keys for the menu itself. And a whole host of other things that I set up. I can set up things that affect, the power configuration on the system. I can set things up for doing a secure or a non-secure boot process. Here's another thing that I configure right here. This trusted platform module. That's pretty interesting stuff. We talk about that quite a bit more in the security training classes. But that TPM is sort of a, I guess the best way to put it, it's sort of like a group hug moment between hardware vendors and software vendors. The software manufacturers and authors nowadays are, when they write a new application or they're writing new files that go into the operating system, they are digitally signing those things. So they are indeed, authoring or signing their files. And all of those files that have been digitally signed, when they're installed on a system that supports this TPM, and you can go here and decide whether to turn it off, enable it, or not enable the trusted platform module systems. When you install the software, it stores those digital certificates. And then when you access any of those files later on, then it validates that digital signature at runtime. And if it's something wrong with it's been corrupted, you don't get to run those files because it could be malware that's been shimmed into those things there. So a whole host of things that I can set up here and change. I can set up things here that address how the system is going to be booted, where it's booted from, the type of requirements. Do you have to have a password to boot the system? That kind of thing. I also can configure these, what they call HSMs, hardware-based security modules, and set up the keys and the encryption algorithms that are utilized with those things. So there's just a whole host of security setup that I can define at using this BIOS menu setup. And remember, the main difference between this and the newer version of it is the fact that the newer version is prettier. It doesn't look like the old navigable menus here. But I also can drive the functions on the newer versions with the mouse. Okay? And like I say, there is a couple of dozen different, probably three dozen now, different things that I can define and configure about the way the system starts up, the way that it's secured when it starts up. And again, down to the level of, for instance, setting up an administrator user ID and password that's required just to boot the machine or required to go in and change the BIOS. So all of those things I can configure with that startup menu there. Now, we looked earlier at the power supply. Power supply is one of the most important components in these, especially in the tower-based systems for sure. Now, when you're newer, your laptop stuff, you don't have that big power supply. You got the AC adapter that plugs in and then charges a battery. Okay. Power supply on these large systems is a totally different beast. Power supplies, as I told you guys earlier, you got to be really careful handling those things, doing any kind of testing on those things, because again, they can retain enough stored up power surges, and even in the little capacitors, to kill you if it all of a sudden releases. And it may not kill you, but it will certainly stand your hair on end if you're not very careful there. But troubleshooting power supplies is something that you may end up doing. If you hear noise, there's a fan that runs in there constantly, and there's a whole bundle of wires and all kinds of integrated circuitry in there. I was saying it steps down the AC current to easily digestible and deliverable DC currents with all of its capacitors and all the electronic components in there. If the fan's not running, it doesn't spin, and was not going to be able to cool the system, that's a problem. If the fan is running and it's making noise, sounds like a Gatling gun, it's scrubbing up against something inside that power supply. There's a clever little testing tool, this guy right here. That's the PSU tester, power supply unit tester device. It's about the size of a deck of cards. And all around the outer edges of that, it has all different kinds of plugs. We looked at some of the plugs that come out of the power supply device earlier. And you plug those into the individual ports on this guy, and it tells you, what level of DC current they're actually delivering. So I can test each and every one of those. Okay. So I need to have that handy. And I'll tell you something, too, about these little portable devices. All of them nowadays are running off batteries. Make sure you have backup batteries in your toolbox when you go out into the field. I found myself, and this has been decades ago, out in the middle of nowhere, South Alabama, at a manufacturing plant that had some systems that we were doing some troubleshooting on. And I had my VU meter, my digital VU meter, and it used a couple of very specialized little barrel batteries, not AAAs or AA's. And of course, the batteries were dead, and I didn't have any extras. I had to drive 22 miles into the little closest town where it had a Walmart that I could buy batteries. And luckily they had them because it's not a well known battery. But I had called ahead and they says, "Oh yeah, we got those. Come on out." So 22 miles one direction. So I burnt up an hour, hour and a half getting there and back, and then finally was able to do the testing on the systems. Make sure you always have those backup batteries in your toolbox when you head out into the field there. Power supply testing, as I said, you need to test the ends to make sure they're delivering the right amount of voltage, and be very, very careful because you have to plug the thing in to make certain that it's, on. You do need to remove it from the computer system, but supply power to it. Be very cautious. Don't be poking around inside it with anything metal that can knock you across the room because it will. But pay attention to what the voltages are. Pay attention to any noise, like say sounds of the fan scraping at something, and certainly if you smell any rubber burning, it's time to replace that power supply. Now these guys can be, they will cost anywhere a couple $100 to the really large server class machines, maybe $1,000, or maybe less now with all of the competition in the hardware world. But nice little PCU tester unit there. Keep that. Keep batteries in it, backup batteries in your toolbox. When any of your computer systems actually boot up originally, they go through a process referred to as the post operation, power on self test. And you guys may have seen this. When a system starts booting up and it has problems, it will either or it may give you a error code on the screen, and it may give you some audible beep tones. Let me give you guys a link here I think you'll like. This is sort of a cheat sheet on I've got it marked in several of my links, but this is easy for me to find it here. There it is, Computer Hope, right there. This is a listing of all of the audible beeps that you may get, and they separate it here by different vendors, by the way. And it tells you if you listen to those audible beep tones, once you get used to the stuff, you might be able to diagnose and know immediately, oh, this beep tone, we got bad RAM cards, that kind of thing. So there's a link for you. Take that to heart. Check that out. On your motherboard, they have this little guy right here. And it's just a tone generator that's right on the motherboard itself. Okay. Looks like this guy right here. And usually it will generate the beep tones as part of the motherboard during the post operation. And the way that the computer actually does that's pretty interesting. When the motherboard first starts to boot up, it basically, the post operation sends out, in essence, a synchronization request is the best way to look at it. It sends a signal out to individual components that make up the computer. First thing it does is checks the power supply. And it basically, the boot up process in the post operation basically asks the question, are you there and are you healthy? And then those systems that get pinged, first the power supply, then it looks at, I think, your disk controllers, your workstation, the controller, keyboard controller, things like that. And it sends those individual queries, if you will. And each one of those things will acknowledge, come back. Yes, I'm here and I'm healthy. Go to the next one. Yes, I'm here, I'm healthy. If it goes through and it tests, I don't know, 8, 10 different components in the system, and if all of those respond to the affirmative, then you see the login screen and you start, you log into the system. If you have any kind of fault there, if you have a power supply that's faulty, or if you have a RAM card that's faulty, or the CPU may be faulty, well, it will deliver very specific beep tones and combinations of long and short beeps. Sounds like Morse code, to tell you the truth. So learning what those beep tones are will lead you towards being able to further diagnose what may be causing the problem. Oh, okay, we got a bad power supply here, need to replace the power supply. And many times the post operation will indeed tell you that. Now, some cases, and it's oftentimes according to the way the computer system is actually configured, computer systems themselves may be set up to, all right, ever so often in the boot process, it will check the manufacturer's website link, and if they have a firmware update, it wants to download and update that firmware update. And sometimes it will trigger a beep tone that tells you, well, we're looking for a firmware update. And along with a message says, we have this firmware update available. Do you want to apply it? That kind of thing. Okay. Now, there are certain things now, and I hope you guys never ever see this screen. It's referred to as the blue screen of death, BSOD. Okay. That typically occurs in during the boot process. And that usually tells you you got a serious problem somewhere. That is usually highlighting a problem with a CPU or a bad random access memory or a boot disk error wouldn't allow me to load the operating system, whatever partition on the disk is located on. Or I may have some malware that's causing this kind of crash here. In the old days, back when I was a young whippersnapper, they used to flash this long hexadecimal error code on the screen. And we had to basically type that, write that down and then use that to further troubleshoot, usually with the vendor of the product, what error that was. Now they've gotten really clever in a lot of the OSs. They are using these QR codes here. And if you scan that with your mobile phone, it will take you immediately to a link. And I tell you, Microsoft and Apple have gotten really good with this utilization. And it takes you immediately to a support screen that will almost pinpoint exactly what is going on with your system. Okay. But you got to hit that QR code real quick. Because, like I say, you get that blue screen of death, you more often than not, you got a serious problem. Okay. So, scan the QR code, go to their support page, and it will begin to direct you in the right down the right path as far as being able to solve that issue. But as far as troubleshooting, especially when it comes to troubleshooting disk drives, again, if you got grinding noises or you're smelling what smells like burned rubber or plastic, we looked at earlier the LED lights on the front of the computer console. There's usually one that burns bright green, showing me that I have power. Okay. Then sometimes there's two others. There's one other one that it blinks rapidly when you're accessing the disk drive, especially the boot drive. And then in some cases, and this one is more often on the NIC, on the network adapter, than it is on the front console, but I have seen them mounted on the front console as well. And that's a light that blinks typically between green and yellow, showing you have network activity. More often than not, that one is closely associated with wherever you plug your network cable in. But if a configuration has changed and the system can't find the operating system, somebody, maybe they booted the system up from an LED or an USB flash drive earlier and didn't change it back to tell it where to boot from on the hard drive, that kind of thing. Or power sags, power surges, somebody kicking the plug out of the wall. That can oftentimes damage boot files or damage an area on a disk where the boot files live. So those are some of the things that may show up initially anyway as disk drive errors, when in truly it ends up being a configuration error. Okay? The system is pointing to a different area on the disk because somebody booted from a different device, that kind of thing previously, and didn't reset the pointers back. Okay. Or, like I say, if you have any kind of electrostatic discharge or lightning storms, power surges do a special damage, and they may corrupt or damage some of the system files. That's all there is to it. Now, this is pretty interesting environment here. It's called SMART Technologies. Self-monitoring, analysis, and reporting technology, SMART. This, and it's software based, it usually is associated with the hard disk drive itself. And the smart technology is pretty cleverly designed, in my opinion. It constantly real time measures multiple metrics. And what it's there for is to alert you. You may need to take a look at disk platter number two, because we've got a high degree of input output, IOPS, they call it, input output per second messages. The IO is not, there's a lot of latency. It's not happening consistently. I may have large chunks or large sectors on the disk that are corrupted or damaged, or I may have a high degree of reported read-write errors. It may be taking an inordinate amount of time for the disk to ramp up to speed, that kind of thing. And it monitors all of those metrics real time. The software does. It's usually part of the whomever you bought the disk drive from, the third party vendor, will include this smart technology software piece. But it constantly real time monitors all these metrics. And like I said, it sort of gives me a heads up. Well, you may need to do a disk clean. You may need to take a serious look at this disk platter on this disk drive, because we're showing a high degree of a possible failure. So it's, again, sort of giving you a heads up that that drive may need to be replaced. So the smart technology pretty cleverly designed there, and it runs all the time. You know, it's a vendor specific thing usually. Here's what I was talking about. You can define your RAID arrays with software, you know, on your existing system. And there's two major things that cause problems, error conditions with RAID arrays. Okay. If you configure a RAID array or are trying to set up a RAID array on your systems, and it just won't allow you to successfully complete it. You can't, the configuration has failed. Okay. Well, that is more than likely a problem with the disk drives that you are trying to configure the RAID are not compatible to be configured as a RAID array. Okay? So that's a configuration issue there. Now, if indeed you have already configured a RAID array, let's say you have two physical disk drives on your computer system, and you configured it as a RAID array and it's been working fine for a while, then all of a sudden it just stops working. If you go in and get something that looks like this, right there, it says missing. That second disk platter has been damaged or is offline for some reason. Okay. So that's where you start investigating there. Okay. And you'll get usually some pretty good information from whatever RAID software you happen to be running, or whatever configuration utility you use to configure the RAID array. And it's usually software that's built into your disk operating system, or maybe your system OS, or it could be a third-party package. Oftentimes it is. But it gives you pretty good information that in most cases will point you to at least an area you can begin to do further investigation. Okay. So again, when you're trying to set it up initially, there's something wrong with the way, and it just won't work. There's something wrong with the way that you're trying to configure it. Or if it has been working fine, there's, you know, everything's a-okay, and then all of a sudden it's just stopped working. Either the platter, like this guy says, it's missing. Now that could be caused by a couple of things as well. Okay. It could be a cable, internal cable has come loose on that individual disk drive. Could be. It could be a bad connector. If you, again, check for that smell of burning rubber or plastic, it may be a damaged connector. It may be that, remember, there's two ends to that cable, one that goes into the disk drive, one that goes into the motherboard. And I mentioned earlier that power supply with the fan that constantly runs. We don't see this occur nearly as much nowadays as we used to back in the old days. Oh my goodness, God, I'm older than dirt. But anyway, we used to have this thing was called chip creep, where not only would chips, because of that constant vibration of the fan on the power supply, the chips would work themselves up out of the sockets. Okay. Or the motherboard, I mean, the RAM cards on the motherboard would vibrate up out of the card slots. Now, most of the new ones have these cantilever locking mechanisms that lock the cards in, so you don't have that much anymore. But still, in all, things like your SATA cables, those things just plug into card slots or to slots on the motherboard and to slots in the back of the drive. With that constant vibration, they can come loose. So check those things. And it's not a bad idea to actually check that kind of stuff on a regular basis while you're doing the cleaning. Because understand, there are dust bunnies everywhere. And because that fan is constantly pulling air in through all of the venting systems, well, it pulls dust bunnies in too. And because of moving parts inside of the computer itself, those moving parts generate static electricity, which acts like a magnet for dust bunnies. So you get these large collections of dust and funk on the internal system components. Well, people compound to that problem because they just take the compressed air canisters with the nozzle and blow into the air vents where you're blowing that funk somewhere inside that computer. Periodically, you need to remove the chassis case, and there's actually a very specialized vacuum that you can purchase. It's called an electrostatic discharge vacuum. They're small canister units. They got long nozzle attachments and pieces, brushes on them. And even the internals on the ESD vacuum are the metal parts are brass, so they don't generate any sparks. You see. So now I'll tell you, those ESD vacuums are expensive. Those things about $400 a piece. But in a large shop, that certainly is worth the money there. Okay. So every now and then, in addition to blowing out the dust bunnies, you need to suck them out from the inside because the computer and the components actually draw them like I mean, it's like a magnet for those things. Okay. Now, your systems and your display devices as well. You're going to find as an A+ technician, and this is it's probably about I would say somewhere in the 65, 70 percentile. The types of things that you're going to find you are supporting on a very regular basis are issues that are associated with printing and or display issues. And the majority of those you're going to find are self-inflicted wounds. Users they've gone in, and especially on like displays, all of your system displays have what's called an OSD, an on-screen display. It's a menu that allows them to adjust things like the brightness, the dimness, the contrast, the tint, the colors, the resolution, things like that. And people will sometimes stumble on that menu, mess around with stuff, not really realizing what they did. But all of a sudden now the screen is so dim they can't see it. And we find too, especially on laptop systems, there are these things that are assigned sometimes to function keys. So you can brighten the screen, dim the screen, turn the sound up, turn the sound down with function keys. One thing my lovely wife had done several times on the new laptop that I got her several years back, there was one of her function keys was the function key that turned her Wi-Fi on and off. So she'd be sitting there and she would hold the FN key down and hit function 11 and not really realize what she had done. But all of a sudden she'd call me, "Hey, the internet's down. I can't." I'm going, "No, I'm on now. You turned it off with your function key again." Yep, she did. So those are kind of things that people end up doing, and especially with printers. They the printer runs out of ink, and we'll talk. We got a whole conversation about printers later on here, but individual things that occur on computer systems, and at large, look for any physical damage. Look to make certain that around all the systems that you got good airflow. Make certain that you do a periodic cleaning inside and out the chassis devices. The heat sinks around the CPU, any moving parts inside the system, especially the power supply. All of that movement pulls dust bunnies in the venting system. You need to make certain the venting system is cleaned out very well so you can have that good airflow. Two major enemies of computer systems, dust bunnies and heat. And an overabundance of dust bunnies causes an overabundance of heat, and then system components start burning up. Okay. So again, in addition to the external cleaning and maintenance on a regular basis, make sure you do that internal as well. But also check the cables, check the cards, make sure everything is seated properly, because that's what causes electrostatic discharge and voltage, deregulation, things like that, and movable cables and things like that in a computer system often end up in burning up components, capacitors and triodes and diodes and things like that. Okay. So that's the kind of troubleshooting stuff we do internally in the system. Okay. And always want to look for overheating problems. Now, I'll tell you too, I talked about my buddy that he and his wife do the online gaming. Users have the capability on computer systems to actually throttle the CPU up. The central processor unit comes pre-tuned to operate at a certain speed, and then all of the CPU vendors will give you some headroom on that thing to where if you know what you're doing, you can go in and say, I want to boost the speed on the CPU, sometimes up to like 20, 25, 30%. Have to understand when you boost the speed, you also are bumping up the heat. So people will boost the speed on their CPU to get some extra oomph out of it, especially if they're doing real-time online 3D world kind of gaming, not realizing the additional heat that they are generating by throttling that CPU up so they don't put any additional cooling in, you see. So that will cause a problem. The CPU may very well overheat and burn up everything all around it, including the CPU. Okay. So again, when you're doing troubleshooting on systems like that, ask those questions, or go in and look at the configuration and then ask the question. Oh, I see your CPU here has been boosted, 25%. Did you do that? Yeah. And then explain to them, the issues that it causes and the additional heat that's generated. So you need additional cooling. So that kind of thing. There's also other, and you can get some of this for free. I sort of have gotten to over the years away from using the free packages for doing like system tuning and diagnostics and things like that because they let too much stuff fall through the cracks. Um, um, once if I'm not looking at physically damaged equipment, hardware oriented stuff, then I want to start troubleshooting and trying to figure out is it a problem with the operating system? No. Is it a problem with any application software I've got running on top of the operating system? No. Well, has anybody changed configuration or the setup on the system? Okay, no. Well, then I start pushing it out further. Maybe it's networking. Maybe it's a connection issue with the closest network switch or router or things like that. Okay. Main question I always ask is, when's the last time we know the system was working properly and what has changed since then? That's where you start really keying in on what may have indeed caused the problems. Oh, and I'll tell you this too, and I hate to drop this dime on my users, but it is true, I swear. Especially if you're supporting a user base that is remote. You're not on site with them. You can't see them. You can't visually verify what's going on there. Believe it or not, they'll lie to you. If they have actually done something that they're pretty sure may have caused the problem, but they know you can't see, you can't verify locally that they've done it, they will be less than truthful in some situations. But bear that in mind. Okay. Now, here's the date and time thing I was telling you guys about earlier, the real-time clock battery, this guy right here. Okay. Those things are easily replaceable. Now, a lot of the new ones I've seen are pretty interesting. You don't take the old battery out. It sits in like a spring-loaded chassis. So you just press the new battery down into it, and there's a clip piece that sort of clips in and holds it in as well. And you have to understand too that that battery, in addition to keeping the clock up and running and synchronized to universal time, it also supports and keeps in place any changes that have been made to the BIOS that we looked at earlier. Um, so if you remove that battery altogether and put a new one in, you may have to go back in and re-up or redo any changes to the master boot record, the BIOS, or anything like that that stays permanent even while the system is powered down, because that RTC battery is used oftentimes to support those changes as well. So just be aware of that. But a real-time indicator that that battery needs to be replaced is your time clock on your computer is not keeping good time. Okay. Now, your video issues, either your local monitor or a overhead projector, things like that, check the lowest common denominator stuff. Is it plugged in? Are both ends of the cable plugged in? Is the source from your computer known to the device, and vice versa? Is the bulb burned out? Has someone gone into the functional setup of this external overhead projector and changed the configuration? Does the projector even aware that there's an incoming signal from another device? And on the local device itself, the on-screen display is where things are configured as far as the characteristics of the device: the color, the tint, the brightness, the contrast, the resolution, things like that. If you see a system and the resolution has been messed with and everything on the screen looks like it's oversized, well, that's one of two things. There is a magnifying glass application that can be used to zoom in on different areas of the screen. That's oftentimes set up for old crusty dudes like myself whose vision is beginning to go, so I can key in on a particular area of the screen. Well, that's a little applet that I can turn on and turn off. But if it's the entire screen, somebody may have gone in and selected a resolution for that screen that is just not a good match for it. So if it seems like half of the screen is hanging off the monitor, well, go into that on-screen display and see if you can let the system, because most of the newer systems now, they have a default suggested resolution for the device, and that's usually the best starting place right there. Now, if you have a system like this, an overhead projector, and well, I've seen some really cool ones out sitting in the palm of your hand. They're just amazing clarity and quality on these things. If it just all of a sudden just shuts down, for no particular reason, that's overheating, no doubt about it. So it may need to be cleaned out in the venting systems there. Okay. So those are just certain things that we look at from a video perspective. Other than that, things that we run into there are misconfigurations. I don't have the proper input video source selected on the device itself, so it doesn't know where the signal is actually coming from, or I've got the incorrect signal selection. Most of these guys now have an HDMI interface for those. So it's pretty easy to configure. And I know on my laptop here, the HDMI interface, if I plug it into any kind of target HDMI screen, it automatically knows that it's a secondary screen. And then I can decide to go in and configure it however I want to. I was telling you about the function keys that control some of this stuff as well. Backlighting, dimming, brightening, that kind of thing. If I have a situation to where either my primary or my secondary screen over the overhead projector itself is flashing, that is more than likely a bad cable. Okay. The connector itself is not properly seated, or there may be damage to the end of the cable, that kind of thing. Okay. So that's, again, some of your video quality issues. Now, you don't see this guy here much anymore, this burned in image. We saw that a lot with the old CRT, the big, the green screens, orange screens, those kind of guys. But the refresh rate on most of our newer LED screens now is, it refreshes sometimes dozens of times every minute. So you don't get that burn in. Now, what you might get is some what they call dead pixels. And I had had an engineer. I thought he was pulling my leg when he first told me this, but it worked. Had a big screen that I was using as a secondary monitor, and there were just individual pixels all over the screen that were different colors. There was like, some of them were red, some of them were green, some of them were blue, and it just one pixel. And it didn't matter what was on the screen, those remained the same. And I says, are those dead pixels? He says, nah, they're just voltage locked. And I'd never heard the term. So that's when I began to think he was just pulling my leg. He says, you're probably not going to believe this, but the best way to fix that is their old rubber hammer method. I said, you want me to beat the monitor? He says, no. He said, take a pencil, a number 2 pencil, and lightly tap the eraser right on those pixels there where it's, the single color. And again, I'm thinking, oh, sure, he's pulling my leg here, but by golly, it worked. But those things are individual micro LEDs, light emitting diodes. And sometimes they get voltage lock, and the last voltage that was sent to it just happened to be that color. So he said that more often than not, that'll free it up. And by golly, it worked. Now there's other truly dead pixels, and they are typically just black spots, one singular pixel, either black spot or white spot, according to whether you have backlighting or not. Those are they're dead. There's nothing you can do about it because you can't replace a micro LED like that. It's just not cost effective to do it. But that's a pretty common issue as far as the voltage lock pixels or sometimes the dead pixels. Audio issues, same thing. Sometimes there are function keys that turn the speakers. Let's see, I have it on mine. I have, what is it? Yeah, there's function 7 and 8 will turn my sound up and down on this keyboard here. So people oftentimes they'll do that with the function keys, not realizing they've turned their sound down or off, even in some cases. So look at the available options on the particular system and adjust them accordingly. Okay. All right, my friends and neighbors here. Now, you folks that are keyed in on the YouTube channel, you're just going to have to hang with us here for a little while because the in-class team now are going to get ready to do a couple of quizzes, and then we're going to have a quick afternoon break. Okay. All you folks in the class here, boogie on over to the lesson quiz screen. Troubleshooting PC hardware, 20 questions total there. Okay. I want you guys to go through that quiz, and I want you to post those scores online. Then I want you to go back and repeat practice quiz number 2, and you will increase those scores, no doubt about it. Okay, 20 questions total there. Now I'm going to only give you 40 minutes to do both of these. And I suspect you'll probably be finished with both of those prior to the 40 minutes. Okay. And then when you return from that, doing the quizzes and post your scores, you may even have opportunity to jump up and take a quick latrine break as well. But post those scores. And we're going to there's a couple of things we want to do when we come back. We're going to go through at least one performance-based question as a class, as a group. And then according to the time frame, we're getting close into it now. We will probably go ahead and dismiss the class after that. But I got a couple of exercises I'm going to do before we do, and then assign you guys homework. But for right now, go ahead and do these quizzes. Jump on these bad boys. I'm going to set your timer up for a quick 45 minutes. And look forward to seeing your quiz scores. I'm sorry, 40 minutes total. That'll give you plenty of time to do and to post these quiz scores, and probably to grab a quick latrine break as well. So looking forward to seeing your scores. Good luck on those. Anybody that is still joining us on YouTube, you are welcome to hang with us for the rest of the afternoon. Lecture is pretty much over for today. but we're going to be doing an in-class exercise that I think you might find interesting as well. So hang with us, and thank you for joining. All righty, folks. That is the end of that particular section there. What I want to do now is to have a group lesson here, and this is showing the one of the. Hold on, I need to a, a group lesson. Hold on, guys. Hold on. Need to Yeah, sorry. I forgot to shut down the sound on the YouTube page that was showing there, so it was bleeding back here. What I do now is to direct you guys over here to the performance-based question page, and we're going to work through this performance-based question as a team here. Now, I want you guys, all of you that have a microphone, go ahead and turn your microphone on. Okay. And these performance-based questions here, when you take your certification exam, you're going to have 3, maybe 4 of these that they present to you right out of the gate when you start your exam. Everything after that is going to be a multiple choice question. Okay. So some of these they're configured with drop-down list boxes. Some of these are drag and drop kind of things. Some of them are configured with check boxes, radio buttons, and some are combinations of all of the above. What this one here is to actually show you, they will show you a copy of the motherboard here, and then they will highlight different areas on the motherboard. You'll see it when I remove the scenario. And then you will select from the drop-down list boxes what those specific areas are. Okay. Now, here's the scenario. You are a computer technician at a computer repair shop. Yesterday, a customer brought in various computer hardware components and asked for help assembling them into a final working computer. The customer mentioned that a friend helped purchase the components and that they should all work together. The customer is not well versed in assembling all of the components. You spent time yesterday assembling all the major components of the PC, including placing the power supply unit, hard drives, and motherboard in the case. Today, the customer returned and you pointed out all of the major connections and components of the motherboard to help educate the customer. Remember, see, that's that whole looking for a teaching moment thing that I like to do. Now, understand when you take these performance-based questions on your exam, as well as when you're doing those as practice, you can display or hide the scenario at will. Okay, either in the real exam or in when you're doing these. Now, as repeat these performance-based questions as many times as you wish, and you should do just that. Okay, so here's the instructions. Based on the scenario, use the drop-down selectors to identify the numbered areas on the motherboard. Now, you guys can key the answers into your chat box. You can just shout them out on your microphone. Okay. Number 1, what is that? Is that the CMOS battery, CPU socket, I/O connections, main PSU power? Is it the PCI Express card slots, the SATA port, the RAM slots? What is that?
IO
Isn't that the
connections.
yeah, the I/O? Because
I/O
it's where you're gonna
connections.
you'll
All
plug in
right.
your microphone and
All right. There we go. I/O connections. There you go. All right. Number 2. What is number 2? PCI, main power supply, I/O connections, RAM slots, SATA ports.
RAM
RAM.
slot.
RAM slots. Very good. All right. Number 3. What is number 3? This is number 3 right here.
Main power.
Is that you say main PSU
Yeah.
power?
PSU
All
power.
right. All right, number 4. What do we have here?
CPU.
Number 4. What is that?
CPU socket.
There you go. Number 5. This item right here. What is that?
Is it the PCIe, the 16, the
All right,
X16
times
slot?
16 slot. All right, we're going to go with that. Number 6. What is number 6 over there?
Oh, that's SATA.
PCIe X1.
All right. Somebody said PCIe X1. Somebody said SATA. Who wants to break that tie?
SATA port.
All right,
SATA.
SATA.
Yeah,
That's
because of the
L.
L.
Yeah.
Number 7. What is number 7 over here?
PCIe X1.
X1 slot. There you go. And then finally, number 8. What is that?
That's the time. CMOS battery.
There you go. Now that the name of that, sometimes it's called CMOS, sometimes it's called RTC, real-time clock battery. So you'll hear it both. In this case, it's CMOS.
Is there
Now,
any
here's the cool
difference?
thing. One of the cool things about the performance-based questions here. When I hit the finish button, it immediately tells us what we got right and if we got anything wrong. Okay. And the other cool thing is while I'm going through configuring this thing, if I need to start over, I can hit the reset button and it sets everything back to how it is originally. Okay. So we will hit the finish button and bada bing, bada boom. You guys are 100% correct there. Okay. Now here's another really cool thing. When you first select the finish, it shows you in good detail here what the correct answers are. Okay. So I can exit out here and come right back in and go into that sucker one more time and run through it again if I wish. And so I can do it again and again and again. And you should do just that again and again and again. Not only with your performance-based questions, but with your practice quizzes as well. Okay. Now, your homework for tonight. Excuse me. I want you guys to repeat all, and as a matter of fact, I'm going to email this to all of you. So I'm going to tell you right now what I want you to do. But I want you guys to repeat once again these 3 quizzes that we went through during class today. Okay. So I want you to repeat those as part of your homework. Okay. Each one of those. I want you to also work back through that same performance-based question that we just did individually, each of you. Okay. So work back through the configuration performance-based question. Okay. So that's the first part of your homework. Now, on the download quiz questions that I gave you guys last night, okay, I would like for you to begin to work on. Let me make sure I'm looking at the correct one. I know all the things that I gave you for download. And by the way, if you hadn't already gone to that wormhole download, you need to do that because that download link will expire later on this evening. So what I want you to do as well is, where is it? The acronym list. There it is. I want you guys to work through your A+ acronym list that I gave you the download link for. Okay. And just go through and study it. I mean, that's all I want you to do. Go through and study those acronyms. And any of those that are not familiar to you, I would highly recommend make you a flashcard of that. Write the term on the front, write the description on the back, and start you a flashcard deck that you can get somebody you know and love to help you quiz those things in prep for your exam. Okay. So I'm going to email all of this homework to you, everybody. And I'm the emails that you guys filled out and that I have in the roster is the emails that I'm sending these to, by the way. So that's the email addresses that you'll be receiving this stuff on. So I'm going to go ahead and set that email up right now while I'm thinking about it.
What if the
And
email that we signed up with is our work email, not our personal email?
if you will give me the email you want me to send it to in the chat box right now, I will update my email list.
Okay, it's the Gmail that I sent you the about me email.
Oh, okay, okay. I'll just grab it from there, Kevin. That'll be fine. Yep,
Okay.
yep. All right, sir. So, lastly, does anyone have any questions that you would like to ask before we call this a day? And I have a little question here as well. Did anybody but me have any fun today? You guys having any fun?
Got a
I
little bit of a
always
headache
tell
started.
I always tell my students, and my wife makes fun of me when I do this, that I truly hope that you all have at least half as much fun as I'm having during this class. Because I mean, you guys can probably tell I truly do love this job, and I love the subject matter, and I love the opportunity and the honor of trying to teach it. But the wife says, you know, if your students are having even half as much fun as you are, then A, they're having way too much fun. And B, they probably need some serious psychological assistance because she says there's a psychosis involved with me digging this as much as I do. And who knows, she may be right. All right, folks, thank you all so very much for trusting me with your day today. We got a lot more stuff we're going to be doing the rest of the week. I want you all to work hard on those homework assignments tonight. And remember, there is method to the madness behind all this repetition. And you'll see. You'll see. All right, gents, you are officially dismissed for the day. Thank you once again. Y'all have a blessed evening, and I'll see you same bat time, same bat channel tomorrow morning, and we'll do it all over again with some new info.
Thank you, Johnny.
Take
See you
care
tomorrow.
and
Thank you.
good night. Thank you all very
Night.
much.